A very good morning, everyone. This is Moiz Anwar, a second year computer science student currently studying in Bennett University, which is a Times of India college situated in Greater Noida. I am currently in my fourth semester, where we have a subject called DAA. I'm sure most of you have heard about this. It stands for Design and Analysis and Algorithms. And in this particular subject, we have certain assignments, such as we're supposed to write a blog on any algorithm, a critical review on the algorithm, and a video explaining an algorithm, which is this one. In this video, we'll be looking on how to solve a knapsack problem, more specifically a 0-1 knapsack problem. And, and in order to do that, we'll be using the brute force technique. We'll also be looking into the time complexity of the knapsack problem and so on. So without wasting any time, let's get started. Okay, so without wasting any time, we'll look into what knapsack problem is. The basic binary knapsack problem entails selecting double attributes objects from a finite set of objects such that their first attribute sum is minimized and their second attribute sum is bounded by a defined lower limit. So we select double attribute objects from a finite number of set of objects. So let's suppose that we have a finite number n, and we are selecting double attributes from that such that the first attribute sum is minimized and the second attribute sum is bounded by the lower limit. Then the problem becomes a multiple choice knapsack problem when only one object from each of a number of mutually exclusive subsets of objects can be chosen. Now we look into what 0-1 knapsack problem is. Now we put the weights and values of n items in a knapsack with a capacity of W to find the rucksack's minimum total value. Okay, so this is self-explanatory that we put the values of n items of a knapsack with a capacity of W to find the rucksack's maximum total value. To put it in another way, you're given two integer arrays, value 0 which goes up to n minus 1, val 0 which goes up to n minus 1, and wt0 which goes to n minus 1, which represents the values and weights of n items respectively. Find the largest value subset of val such that the total of the weights of this subset is less than or equal to w, given an integer w that denotes knapsack capacity. You can't shatter an item. Either pick in its entirely or don't pick it at all. 0-1 property has to be applied. So we look at the question given to us. The value is given, the weight is given, the w is given, and we also are provided with the solution. So we first make a chart of weight value respectively, and then we sum up the total weight just to make sure whether it is greater than 50 or not. Now we look into the process which we'll be using to solve this particular knapsack problem. As I mentioned earlier, we'll be using the brute force technique. Now, what will be our approach? Now, we consider all subsets of items and determine the total weight and value of all the subsets for a simple solution, only to take into account subgroups having a total weight of less than W. From all of them, choose the subset with the highest value. The best performing substructures is, in order to consider all subsets of item, each item can have two cases. Case 1, the item is a part of the best subset. Case 2, the item isn't part of the ideal set. So basically what is happening here is we are considering all the subsets of items and determining the total weight and value of all the subsets of the original set for a simpler solution. We are only taking account the subgroups having a total weight, which the total weight is less than W. We are only taking those subgroups into consideration. Now from all of them, we are choosing the subset with the highest value. The best performing substructure in order to consider all subsets of items. Each item can have two cases, which I mentioned earlier. Case 1 can be the item is part of the best subset or the item isn't part of the ideal set. As a result, the maximum value that can be derived from n items is the sum of two values below. With n minus 1 items and w weight, the maximum value can be attained, excluding the nth item. Remember, you have to exclude the nth item because it goes up to n minus 1 items. The sum of the nth item value and the item's maximum value. Now, if we want to see how we can solve the problem using a code, then it's this. We first define two variables a and b and use a maximum value, maximize them. And then we define a knapsack value of w, wt, val, and n. Then we compare them, and then it's, it is what it is. So I hope the code is self-explanatory to you all, and the output for the particular code will be 220, as it is a desired solution, 220, which was already provided to us in a question. Now, it should be observed that the aforementioned function repeatedly solves the same subproblems. See the recursion tree below, where k11 is evaluated twice. This naive recursion solution has an exponential 2 power n time complexity. Now we look into the time complexity for the given knapsack problem. The time complexity for this 01 knapsack problem, is O to n, as there are redundant subproblems, and the time complexity for the 01 knapsack problem is O1, as no data structure is being used for storing values. This problem has the overlapping subproblem attributes because subproblems are evaluated twice. As a result, the 01 knapsack problem possesses both dynamic programming features. Pseudocode for the given 01 knapsack problem, the knapsack problem that we just saw. And if you want to have a look at the pseudocode, then it is this. The pseudocode looks something like this. Now, in conclusion, through the above article, we learned how we can solve the given 01 knapsack problem, its types and its formulas. We also saw the code and the pseudocode for the knapsack problem, and we learned the implementation for the same. Thank you.